Hello viewers, welcome to ECE Sradha Ocean. My name is Suresh Kumar. This is the third question from GATE 2019 ECE paper. In this question, they given a function p of z equal to h of z into h of z and 1 0, that is at z equal to 1 by 2 plus 1 by 2 j. And they are asking, there are 4 zeros and we have to identify the remaining 3 poles. For that, initially I will consider the first 0 like this. 0 z1 is equal to given condition is 0.5 plus 0.5 j. If a complex number is a 0, obviously its complex conjugate also becomes a 0. So z2 is simply the complex conjugate of z1. So I can write directly like this: 0.5 minus 0.5 j, and remaining 2 zeros will be like this: z3 is equal to 1 by z1 and z4 is the complex conjugate of z3. So I have to find what is z3. z3 equal to 1 by z1, that is 1 by 0.5 plus 0.5 j. I have to convert this denominator into real. For that, I will multiply with its complex conjugate 0.5 minus 0.5 j, and I will divide with the same 0.5 minus 0.5 j. So the numerator becomes 0.5 minus 0.5 j, and the denominator becomes 0.5 square, that is simply 0.25. Actually here we have to write minus, but there is a j term. If we square j, I will get minus 1. So minus minus becomes plus, and again 0.5 square is 0.25. So the denominator is 0.25 plus 0.25. It is simply 0.5 minus 0.5 j divided by 0.5. So if I simplify this, I will get 1 minus 1 j. So this is the third 0, and fourth 0 is simply its complex conjugate. So z4 is equal to complex conjugate is 1 plus 1 j. So these are the 4 zeros. So if I verify in the options, see here, option D, here this point represents 0.5 plus 0.5 j, and this point represents 0.5 minus 0.5 j, and this point represents 1 plus 1 j, and this point represents 1 minus 1 j. So option D is the correct answer for the given question. Thank you.